Hi everybody, today's episode is intended for those who are new to Godot and want to kind of have a recap and a refresh on the things that we've done over chapter 1. I'm also going to include towards the end of the video just a couple cleanup and minor changes, so you might want to skip forward to that if you're more experienced. So stay tuned. Hey everybody, so in this video I'm just going to kind of recap some things, talk about some common questions that I've had, and I'm probably not going to hit all of your deepest questions, but I hope to address a couple of the big ones. And then maybe we'll do just a little bit of work to kind of clean up and polish just a tiny bit, just in preparation for the next chapter. So where I'm going to begin with this is talking about the state machine. I'm just going to kind of review it for those who are maybe still struggling with the concept of the state machine, because if you're new to code, it might be confusing, like, how are we calling the enter? How does it do this? How does it do that? And then I want to talk about my decision making when it comes to where I put my code. And what I mean by that, I've had a question about how do I decide when to use process versus physics process? And so I'll talk about that a little bit and give kind of my insight on how I make that decision. And then I'll just talk about a couple of general things that have come up, like our gravity settings and just some general advice if you're going to continue working with this state machine. And lastly, we'll clean up those debug displays like the jump indicators and stuff like that, and maybe make a tiny bit of a refinement to the jump via the character body 2D settings. And that's what we'll cover today. Okay, so let's just dig into this state machine and talk about the code and how does it work. Because I think for many of you it makes sense, but for some of you there's still maybe a disconnect on how things work. So let's just open the player. In the past, if you followed previous tutorials of mine, or maybe even followed somebody else's tutorial on a state machine, it's pretty common to have a script, or in case of Godot, maybe a node that is the state machine. So for example, this states node, in my previous video, I had a script on the states node that handled and managed the states and the transitions. What I've done with this Metroidvania series is I've just kind of integrated that into the player because, for the player character, there's not a whole lot of modular customization during gameplay. And so it just made sense to just make all the code a little bit more tightly coupled. And so that was a decision I made. So essentially the player script is the state machine. And what I mean by that, if you don't understand what that means, is here in the player script is where we handle things like, let's see, we've got our change state function. Okay, that's a function of the state machine. The state machine controls which state we're currently in and transitioning to next states and things like that. Okay, so the change state function, we just pass it a state, and then this function will change to the new state unless it doesn't meet some of the criteria, right? So like if for some reason we pass in a null, which we actually do all the time, we'll look at that in our code, then it says, oh, okay, we're not actually trying to change state. If this new state that we're passing in matches the state that we're currently in, then it's just a mismatch. We don't need to change, right? Because we're already in that state. But otherwise, then what it'll do is it will call the current state. This is where I think it gets confusing for some people. The current state refers to, let's see, if we look at our code here, the first state in our states array, which is the one that we're currently running all of our code on. So when we're accessing that, we're accessing its code, and we're going to, where's that change state function? We're going to call its exit function, okay? Let's go ahead and pull idle up as an example. So if we were in the idle state and we were to change to a different state like run, and we'll pull up run as well, so we'll have both of these. But if we were to be in idle and go from idle to run, then what will happen is we'll call the exit. Now nothing happens in idle in the exit, nothing happens in run in the exit either. In fact, I think the only state right now that has a condition is it fall? Which one has an exit condition? Yeah, there we go. We've got a player gravity reset here in our fall state, okay? So then looking back at our player state script, which is the state machine, it's going to call that exit code, and then it will add the new state to the top of our list of states, so now it's the new current state, right? And then we just call the enter function on it so that we can do whatever it needs to do. Now the enter function is pretty obvious, right? So we've got fall. We looked at that. Let's close fall. Idle. and run are good, simple examples, but the enter is just going to typically play an animation and then maybe do some configuration of some other settings within the state. Okay, some things that maybe need to be initialized. And then this resize just keeps the list to 3 states max. It just cuts off the last ones. And then this last line is just a debug, so we could disable this and remove this when we no longer need it or when we no longer want it. But that's what that change state does. So I hope that makes a little bit of sense, right? And because we do this kind of interchangeably, it just depends what state we pass in. All of our states follow that same pattern that's defined in the player state script. So they all have to have an exit and an enter function. Okay. They also all have a handle input function, a process function, and a physics process function. Okay. Which means we're just defining. So if we're in this state, how do we want to handle our inputs? What do we want to do during the physics process or the physics process when we're in the current state, right? And how that works is in our player state machine. If we look at the process, for example, or unhandled input, this is probably the most confusing for new people. What we're doing in unhandled input, process, and physics process, you'll notice we're calling the change state function in all of these, okay? And change state wants us to pass in a state. So this is where it gets kind of confusing. And so we're passing in that state using another function, which is the part that I think gets confusing. So looking at unhandled input, or let's look at process. So for the process, we call change state and we pass in the current state's process function, right? Which many of you are thinking, well, what does that do? What does that mean? If we look at any of our state's process functions like idle, this function returns a player state, which means every time this function runs, it's going to kick out something. It's going to give us either a state, or in the case of next state, this is null, because that's how we've defined it. And in fact, we haven't really used the next state variable too much, but let's just change this in my code right now so you get a better, clearer, transparent view of what's happening. So in the player state, during a process function, it's either going to return null, or if either of these conditions are met, then we'll return a different state. Okay, so every time the process happens, we're calling this process on our current state, and we're getting back the result. And then that result gets passed into the change state. And this is why when I said earlier we call null all the time, because we do, because in our idle script, we may not be returning run or crouch, right? If you're not pushing anything, then it's just going to continue to return null until this player direction changes. Right? That's the only way you can exit the idle state right now. Well, no, that's not true. There's also this one from the handle input, but from the process function, those are the only 2 ways to exit this state. Okay. So as soon as one of those changes, suddenly when it calls that change state, it's going to give us a new state, and then it'll do the change. Okay. So I'm hoping that makes a little bit of sense. Let's go back up to our process. Just like that in our unhandled input, we just say, okay, well, let's try changing state based on the current state's handle input function. And when we look at idle, this is going to return next state or null, unless we press this is action pressed jump. Okay. So if the player just pressed the jump key this frame that this ran, then what will happen is it's going to return the jump state. And now our player state machine in the change state is going to pick that up. It's going to change it to the jump state. And likewise with the physics process, we're doing the change state here, and we're just calling that physics process function, which in most of these we don't have much, but we do have a check if they're on floor to return the false state, or if we're not on the floor to return the false state, right? And if we look at run, it's a very similar set of things. If we press the jump button, we return jump. If our direction becomes 0, then we return idle, or if it becomes down, we return crouch. And if we're not on the floor, we return the false state, okay? And so these functions here are just running all the time, and they're getting called from our player state, but we're only calling the one of the current state, whichever a state is our current state. That's the only one that gets its physics process called any given physics frame. Same with process and unhandled input. All right. Hopefully that makes some sense, and that clarifies things just a little bit for those of you who are new to the state machine. And so what we've done is we've just isolated the code of how we want to handle the process, physics process, and button presses per state. And then we just call the currently assigned one, its respective functions, each frame or each unhandled input, etc. And that's what the player state machine does. Now, from here, we can get into this second topic, which is how do I decide what to put in the process or physics process, or even the unhandled input for that matter, because we can do input detection in the process function, for example, or in the physics process, but why do one place or another? And really what I do when I'm writing my code is I just try and ask myself, first of all, for unhandled input, if it's a button press, the majority of the time, we only want to respond to button presses in the unhandled input. And that's because if we do it in process, that means every frame we're checking to see if a button is pressed. And the unhandled input function in Godot is designed to make it a little bit more lightweight on the engine. And so this unhandled input will fire when a button is pressed, and then we just call that, right? So for that reason, the most performant way to check input handling is in the unhandled input function, okay? I think that one's the most self-explanatory, pretty straightforward. That doesn't mean you can't check outside of it, but I certainly wouldn't recommend doing a lot of input checking outside of the unhandled input. Now, when it comes to process and physics process, the general rule is simply, does this affect the physics body or collision detection of the object? And if it does affect the physics, like if you're applying a force, if you're checking for collisions or something along those lines, then it pretty much belongs in the physics process. If it does not, if we're doing something to our object that is, just updating anything else like animations or just setting general settings, then we just do that in the process, okay? That's the general rule that I follow. Now, I do kind of maybe go back and forth a little bit on that rule to some degree, but a good example here in our physics process, move and slide is an exclusively physics process kind of thing, right? This is where we're taking the velocity on our character body and we're using it to move our character body through the world. And so move and slide is a very exclusively physics process kind of code. Now, if we look at like the idle state or the run state, you'll notice I am setting my player velocity usually here in the physics process, right? Now, I feel like this could be done in the regular process only because the velocity, setting the player velocity in and of itself doesn't move the player. It's the move and slide code that moves the player. So you could theoretically put this, this player velocity setting in the process function and it wouldn't work any differently, I don't think. But that's just the general rule, right? Like here in our physics process, we're checking if we're on floor. This is on floor. That's a collision detection kind of a call. So we want that in our physics process. Here in our regular process, though, we're checking to see if our direction is changed, which is based on input. I know we said input handling stuff here, but this is a different way of doing input detection, right? Because we're just checking the value of a variable to see if it's changed. We're not actually checking an input here, just the result of that input. And then likewise, we've got, of course, our unhandled input stuff happening there. I think jump and fall are good examples of how we use or how I use these different functions differently. In the process of our jump and fall, I'm doing a set jump frame, which is where we're calculating and setting the animation frame. And that's good to happen every frame because that way the game will update the animation as smoothly as possible, running along with our engine. And then likewise, we've got our is on floor checks and things like that happening here in the physics process, okay? Now, one thing that I think I want to talk about that is a little bit unusual that I've done here is when we look at our player, I've defined a gravity. Where is it at? Down here. I've defined a gravity variable. Now, and I've seen this in some people's code, there is a gravity in your project settings. So if we go to our project settings here and then look for physics, in fact, maybe I'll just type gravity in the filter. It'll get there quicker. So if we look at our 2D physics, there is a default gravity. And if you'll notice that the default for a 2D game is 980, just like I've set it. You've even got a gravity vector. So obviously y1 means down. And if you were to add x to it, then, your gravity would start to get an angle. This could be fun if you're doing some kind of gravity manipulation game. You might want to just update these variables and your gravity will change. You can, and in fact, it's probably best practice to use this default gravity. I like to just have it hard-coded here because, if I'm making a player and then I make an enemy, I may not want them to rely on the game gravity because I'm going for a different feel for each thing. If you've got an enemy that's kind of floaty, if you rely on the game's gravity, you could do that. You just would need to use something like this gravity multiplier to make it feel more floaty or fall more slowly. Okay. So this is just a preference thing, really. I just like to put the gravity in here because then I can see it without going to the project settings. And if I want to change it on this one entity, then I'll just go there. That's all. That's the only reason I really do it. So it's not a big deal. I want to talk a little bit more about these state machines. One thing that I've seen, and I've done a lot myself, is I over-engineer the state transitions, because we've got a lot of simple transitions. Like, for example, the idle state can return crouch. Now, it's tempting in the fall state to also have, like, let's see, where's the physics process? When we hit the ground, when we're on the floor, it's tempting to want to return, to do a check. And if we're pushing down, then we can return the crouch state instead of the idle state, right? We're doing that for jump. Now, that's fine, but I think that can get too complicated, especially as we add a few more states. Because really, if you return the idle state, then he'll idle for like literally a tiny fraction of a second, and then he'll begin crouching, because the crouch would get triggered the very next frame of the game based on our code. And so you can kind of keep that in mind. Like, sometimes you can use the idle state as the go-between from one state to another state. And you may find similar relationships, with like jump and fall, and we'll have like dash. So just be careful that you're not over-engineering and doing too many checks, because you might just be doing extra work for no perceived difference in gameplay, So that's just one thing, just one pointer I want to give, is you're working on your own abilities and, adding states to the state machine. Just play around with it and try and get away with the minimum number of checks. And it's also just nice performance-wise to have fewer if statements. These kind of conditional statements tend to be a heavier kind of a check or calculation to do every frame than, say, a simple addition to a value, adding +1 to a number or something like that. Okay, the last thing I want to do is I want to just kind of address a couple things, and I'm going to come into our player, and we've added, in fact, let me just demo the game real quick, and let me see if I can demo one of these issues that I know some of you have run across. But we've got this little debug display. Not loving that. I mean, it's good for testing and it served a purpose, but we'll remove it. We can add it back later if we want to. The other issue is sometimes there's a little bit of a like fall state. It's not happening a whole lot right now. It just happened as soon as I went off that ledge. Depending on the slope of the angle of your sloped ground here, you may see where your player is like constantly shifting between run and fall. And that will depend on a couple factors. It's going to depend on the slope. It's going to depend on the movement speed of your player and the gravity of your player, and kind of several different factors, right? So let's see if we can reproduce that. And I want to show you how we can help remedy that, at least to some degree. First, though, let's just look at how we can disable the little indicators. So we're creating those with this add debug indicator function. And I'm going to actually leave this function in place so that we can use it later if we want to. But I'm just going to come into the code where we add it and just disable it. So in jump, for example, we add a debug indicator here in our enter function. And so you could just comment that out. And we also do one when we exit the jump state. And I think that's it for jump. Likewise, I think we've got one or two in the fall state. So let's see, what do we got here? Do we have let me just do a search for indicator. There we go. So we've got an add debug indicator when we land on the floor. Just go ahead and comment that out. And in fact, one thing we can do is I'm just going to copy that little bit of code, and I'm going to do a Shift Control F and do a find. You can see that it already put in the find field what I had in my clipboard. And what the Shift Control F is, it's find in files. It's going to search our whole project for that exact string or bit of code. We don't want to replace. We're just going to click find, and looks like this is the only place it's really appearing is in our fall. That doesn't make sense, does it? I mean, jump, we have, oh, these ones we have a color. Let's do this. Let's do Shift Control F. Let's just have the opening bracket there and find that. Okay, there we go. So this is going to give us a result. We can click on these to jump to the file. So the first place it found it is in the player script. That's fine. We're keeping that. It found it here twice in the jump script, which we've already commented out, and a third time here in the fall script. So we've caught all of them just going through, but we're just going to turn those off, get rid of that little debug display. And then let's look at our player here. I'm going to do something. There is a setting on our character body 2D that helps with that slope issue. Okay, we've got a few settings in here that we didn't really deal with. They're in this floor section, right? So we've got a stop on slope, which was on by default, which is good, so he doesn't just keep sliding down a slope. Generally, for a game like this, we don't want that. There's a constant speed, which means that the slope isn't going to affect his movement speed. We may even want to turn that on. I don't know. Block on wall, that's fine. That's on by default. We've got a maximum slope angle. This is the maximum angle of a slope that will allow the character body to move on it before it essentially considers it to be a wall. Okay, so you could increase this. I think 45 degrees is good. Now there's this snap length. Okay, let's see if I can get the tooltip. This is the snapping distance. It says, when set to a value different from 0, the body is kept attached to the slopes when calling move and slide. The snapping vector is determined by the given distance along the opposite direction of the up direction. So right now, this floor, the snap length is 1. I'm going to set it to 0, and let's just try this out and see what happens here. Yeah, you can see when I do 0, I'm getting that run and fall state. He's like constantly falling. Okay. Many of you saw that issue, and it will probably have been improved with the default snap length of 1 when we changed our collision shape to this capsule shape. Because when we had a rectangle, you can imagine if we've got a slope going across, that we're detecting our snap length from essentially the lowest point. And if it was a rectangle, then we might barely be sitting over here and, you know, rise over run, right? Depending on your angle, your snap might have been 2 pixels away from the feet of your player. But even if you're still having that issue with this capsule shape, you may want to increase the snap length. I wouldn't make it too large. Like we could set it to 2 or 3. I'll just try 3, for example. We know that this is going to fix it for me, but because it was already working on 1. But you can see that there's a difference, right? And that floor snap is a nice feature that's built into this character body 2D. It really makes slopes really simple to use. I see a lot of people say that slopes are super buggy and complicated, and so they always avoid slopes in their platformers. I think if that's the case, they might be doing something wrong, or maybe not using the character body the way that the Godot developers intended it to work with slopes. Because when you do, it seems to work quite well. I'm going to just decrease this just a tiny bit to 0.5. I want to see what the threshold is for me to even see this snapping issue. Yeah, 0.5, half a pixel, quite a bit difference. Let's go ahead and make this really big. I've never tried this. Let's make it 20 pixels and see what happens. It's probably not going to do anything because you probably kind of have to be on the floor in the previous frame. Yeah, see, that's not even breaking anything. I was wondering, is it going to like try and snap him to the ground? But if you're jumping, it's still going to allow you to move vertically away from the floor. It's just going to snap you to it as you're walking along a slope or something like that. Okay, but I'm going to reset that. 1 pixel is a good setting for me. And that's all the cleanup I really want to do with this. These are pretty minor bits of cleanup, but that snap length may be something that some of you need in your game. So there we have it. I appreciate everybody who's been following along for this first chapter of the Metroidvania Forge series. I know it's kind of in-depth and slow. Some of you are probably chomping at the bit to get to chapter 2. I mentioned I'll be on a brief hiatus. I've got a little bit of prep work to do before I'm ready to begin recording that chapter, and I want to prepare a few assets that I'll make available on my itch.io page so that you'll have some tile sets to work with. And that's going to be beneficial to you if you're not really into doing the pixel art. You'll have at least a few things to work with. But I will also provide some templates that you can use if you are interested in developing your own tile sets. And that will be part of what we do in Chapter 2. We'll talk about how I make tile sets, some common practices, and of course this template that I'm providing, I'll show you how I use that to make auto tile sprites and things along those lines. I'm also going to be doing some work for the action RPG series, so I'm going back to the cutscene and kind of tying up several loose ends on that one as well. So I'm going to be making some other videos in the meantime, but hopefully I'll get back to the Metroidvania Forge series within a week because I'm really having a great time with this project and I really look forward to just moving forward with it and maybe seeing if we can, I don't know, rescue Pink Box Hero or bring him back from the dead, or who knows what will happen with our new hero as he seeks revenge for that. But yeah, go ahead and subscribe. If you're new to the channel and you want to see what's coming next, subscribe. It helps me grow. It's one of the best things you can do. Drop a comment if you've got questions. Let me know what you're looking forward to in Chapter 2 of this series. And as always, we'll see you next time. So just a little preview of what's coming up in Chapter 2. These are some of the tiles that we're going to be working with. These were developed during one of my game jam entries. So that's the Millennial Warrior. You guys can check that out. You can find it on my HIO page. It's not too hard to find. But I am going to be adding to this tile set. But with all that said, I'm going to give you some basic versions of this. If you're a Patreon supporter, you're going to get an expanded version of this. In fact, you're going to get a full complete version. What I'm working on in the background right now with these little tile sets is I'm working on a pretty comprehensive and complete set of tiles for exterior, dungeon, castles, and things like that. And that's going to be part of a whole package that I'm going to sell on HIO. And so Patreon supporters of the Pixel Adventurer tier are going to have full access to that as I develop it and release the various parts of the package. And even if you're just a supporter on Patreon, I'll give a few freebies here and there. You'll get a few extras. You won't have access to the full sprite sheets, but this just a little preview. Oh, look, I've got a dash. That will not be chapter 2. Double jump? Anybody? Double jump's actually pretty easy. I bet most of you at this point could implement a good double jump and dash with the knowledge that you've got. I wanted to say thanks to the Patreon supporters. I've got a few more now than I've had, and I'm trying to make it worthwhile to you guys. And really, this asset pack that I'm doing is a way that I'm growing my brand and my business outside of the tutorials. And so I just want to include you Patreon supporters in on that journey, because if it weren't for you, I wouldn't be doing this at all. So thanks, everybody, and looking forward to making games with you.